All right, guys. Anybody have questions from anything? Any homework? Anything? Any questions? Yes, that's true. If you had all the war criminals and they were like dwarf characters, then he would be dopey. For certain. Yeah, the word dopey doesn't normally go with war criminal, but now it does. Thank you, America. Sorry. All right, that's enough of that. Because if you feel differently, I don't want you to feel bad or anything. I sort of do, but no, I don't. Anybody have any questions from any homework stuff? Get me off the topic of elections and politics. All right. If no one has any questions, then I'm very happy everybody remembered to, well, even if you forgot to change your clocks, you were just up early. So that's always
that
nice.
threw me for a loop.
Well, like most of your devices now automatically update. So.
Wait, the time change?
Huh?
Yeah. Yeah. Like I woke up on Sunday, my clock said my phone said one thing, my body said another thing, the clocks on my wall said another thing. And I'm just like, what the hell's going on? I think Google's broken.
I was so tired yesterday. I didn't even know.
Yeah, man. Yeah. Of course, spring is worse when you lose an hour, but hopefully they'll stop doing that. All right, guys, let's focus. Anything from homework? No. If there's nothing from homework, I'm just going to launch into some other stuff.
I have one quick question.
Yes.
I was on number 9, and it doesn't look particularly complicated, but I kind of ran into a wall figuring out how to get it right on 3.6.
Yeah, that's the one about the map, right?
Yeah.
So the thing that they're not really clear on in these problems, well, on number 9, you just use exactly what they tell you here. So I was grading a few papers, and some people just kind of skipped over this. 1 inch on the map corresponds to 2,000 feet in real life.
Right.
So it just set up that ratio. That's all. That's all number 9 wants from you.
Okay.
Yep. That's it.
I hated that one.
Number 9? Or you mean the
not
map?
Number 9, when they asked you if you were able to see a boat or a river.
Oh, I see. That's a total opinion. So a reasonable answer would be, I don't think so, because it's so zoomed out. You with me? And then they make you do the actual math, and you're like, well, maybe you could see a little speck. Everybody with me? That's an opinion question.
Yeah. Well, yeah, for that one, I actually did the math, and I went to the next question. I was like, I just did that damn thing.
Well, great. Then you can just say, look back at 12. That's not bad. I like that. That's awesome. So math becomes one of the tools you could use to figure something out. That's the whole point. Anything else is that all right? Ian, is that enough on number 9, I guess? And does anyone else have anything else?
Yeah, sorry, someone was knocking on my door.
Oh yeah, you're fine. Okay. All right. So no other questions. We're just gonna keep on going on. What we're about to do. Let me do this so I can, because I got to be the center of attention. All right. We are getting into an interesting area. We're gonna create a different equation of a line. So what equation of a line do we already have? Can somebody tell me what's the equation of a line that we know right now?
Y equals mx plus b.
Kick ass. And then you can wonder, why would there need to be another one, Jeff? Well, because what do you really need to know directly to be able to use mx plus b? M, of course, is the what?
Slope.
And what's b?
Y.
Y-intercept. The y piece of the Y-intercept. I like it. All right, so what I think I want to do, all right, I'm curious. This is interesting. The book does it in a different order than I'm used to, which is really intriguing to me. Let me see, where are we? So the last thing we did was the one about the alcohol. Remember the blood alcohol content stuff? Let me pull this up real quick. We went through this. I'm hoping that this homework in this section 3.7 will be relatively straightforward compared to some of the other stuff we've done, right? We looked at this a little bit, Bubba, Buddy Bubba, I have no idea. Anyway, so that homework should be, even though it's a little bit longer, it's got a lot of stuff we've talked about already, sort of like put together. So what we're about to get into is section 3.8. So I think I am going to follow the book. While I'm talking to you, I'm trying to figure out which order do I want to do this stuff in. I'm going to follow the book for the first couple things. Then I'm going to go up on the board and do my own thing for a bit. Bluetooth mode.
Bluetooth.
Thank you. Ooh, nice sound. Okay, Jeff, you really got to clean this desk up. So we're going to follow this along. So if you got your book, it's page 393. We're going to follow this sucker along. It's going to be kind of nifty. And we're going to use some skills that we've picked up on the way. So let's see what happens. By the way, I don't know if you guys have realized we're analyzing the hell out of lines, which is not a bad idea because it kind of confuses people. It normally goes word problems and then lines and graphing as far as what people really dislike the most. So read through this whole thing up here. Congratulations. Read through that real quick.
Awesome.
Oh, what's up? Everybody all right? All right. All right, so we can see the important information. If there's 150 people, it will cost this much. If there's 200 people, it will cost this much instead. It'll go up by a bit. Can you just take a minute? Yeah, screw them. They're taking too long to do this stuff. Can we just figure out, do we have enough information to find a model for the cost? This is an interesting question. And when they say a model, they really just mean an equation. Math equations are how we model real life. All right. Do we have enough information?
Yes.
Yes.
Yeah, we actually do. I don't know if everybody agrees. Do we know the Y-intercept? Let me start off instead by saying this. Do we know any points that this line goes through?
Yes.
Yes, we do. Somebody tell me one of them. And let me go even further. So go ahead, sir.
150 people and $6,500.
Yes, exactly. How did he know to put it in that order? Because what would be the independent variable? And what's the variable that depends on that other one? So which thing, cost or people, which one depends on the other one?
Cost depends on people.
Cost depends on people. So cost is going to be Y and people is going to be X. Is everybody with me? That's how I know what, and that's how he knew the order to put that in, right? And what's the other point that we're working with then? Somebody else.
200 and
208,500.
I love it. Now just take a minute and figure out the slope for me.
every 50 people, like it's cost 200, 2,000, I mean.
Okay, so now make that more precise, be more mathematical. What goes on the top of the slope? Sorry.
50.
No, careful.
Oh,
What's the
gosh.
slope? Somebody tell me in terms of a ratio what the slope is.
It's $40 per one person.
No. I'm sorry.
Oh.
The
I go
idea of
one.
slope. The idea of slope. What's the idea of slope as a ratio? In
Oh,
general.
got it.
Negative.
So y2
Y2.
minus y1.
Okay, good. All right. So one way to answer that question is with an equation. I love it. Right?
Rise
everybody-
over one.
Beautiful. Another way to answer that question is with words. Why does it make sense that rise is wise? It's beautiful that they rhyme. That kicks so much ass. Rise and wise rhyme. So what goes on the top? Rise. So what goes on the top? Wise. All right. If I change my y, in what direction do I go? If I change from 1 to 2, didn't I rise? And if I change my x from 0 to 1, don't I run? Meaning run along the ground, right? So that's why it makes sense we call rise the part that goes with the y's, because y is fall or rise, and the x's is run forward or run backward. All right, I like it. So let's catch up with the number somebody got. So the slope would be 8,500 minus 6,500. Why? That's y2 minus y1. That's how much the y's changed. Over 200 minus 150. That's how much the x's changed. So then I get 2,000 over 50. And then we finally catch up and we get 40. 40 what? What's the units? What's the units on the top?
Dollars.
Dollars. What's the units on the bottom?
People.
People. It's people. All right. So this will be dollars per person. That looks like 140. How did I do that? Jeff, you silly person. Now it looks like 10. Hold on. Crappity, do that. There we go. All right. So the slope is a mathematical idea, but it has real life implications. It always has units of something per something because it is a ratio. It is rise over run. So whatever the hell the y variable is the top unit. Whatever the hell the x variable is the bottom unit. It's almost too nice to believe. And it makes physical sense. $40 a person. That's some shit I could just hear in real life. Right? All right. If anybody's been married or just threw a big party, yeah, per head is normally the way it is talked about. Like, you know, who cares if they bring their body? I don't know. That's kind of creepy. Do we have enough information? Does anyone know? I think I already asked this. What's the Y-intercept? Do we know? Somebody might be able to figure it out, but I'm not interested in that at the moment. Do we know what the Y-intercept is? No.
6,000.
Yeah, you could kind of figure it out. You could kind of work your way back. You go down 50, you go down 2,000. You can keep going down 50 until you get to 0, right? I'm going to give you a better way to do it. Don't we have this equation? And like I said earlier, you cannot use this equation directly and get the answer, bam, unless you know M and B. What do we know? We only know
M.
M. We only know M. So let's put in what we know. Now, what I just said is incorrect. I don't only know M. I actually have two situations. Is everybody with me, right? I know we've been analyzing the hell out of these lines. I know it. I know. Just do it a little bit more. What does X represent again?
People.
People. I love it. And what does Y represent?
Total cost.
Money. Money. I like it. So this is something we're used to from that variation part when we did the varies directly stuff, the direct variation. Can't I take one of these pieces of information and plug it in? So here's how it's going to work. So in this first point, for example, what's X?
150.
150. So let me put that in there. 40 times 150. And what's Y?
$6,500.
6,500. Let me put that in there. Take a second and solve that for B. So let's see, you get 6,500 equals 6,000. I believe I can fly. And then you subtract 6,000. And you end up with B is 500. The mistake people make when they do this way. And by the way, so before we just knew this. They gave me 0, something. So we just put that number there. Now we had to do a little bit of work to figure out what B is. But some people will get here and they'll just circle that. No, the answer is the equation. So now how do I finish this equation out? Y equals 40x plus 500.
So would the $500 be like what? The amount of money it costs to rent out the spot or something?
There you go. I love it. If you had nobody come and you just wanted the room just to sit in, it would cost you $500, right? So this 40 per person has got to be something related to the food and, you know, whatever, the drinks and the tableware and the tables. And you guys kind of with me? So the $500, like you said, this was probably related to renting out the area, the banquet hall. Is everybody all right? You guys doing okay? I'm so worried about you guys. So the one new thing here was we didn't know what B was to begin with. So we just had to figure it out. It's sort of like in the direct variation, we need to solve for what the K is, right? What the number is that goes in there. Maybe? Okay. I'm going to take your silence as we get it, Jeff. Move on. Now, that will always work, this method we're using. But there is a valid reason why we want to develop a new formula for a line. So what I think I want to do is I want to come out of the book. I'm going to go up to the board. So I'm going to stop sharing right now. Is anybody still copying stuff down? You guys good? All right, here it goes. Bye. Okay. So come up to the board. I feel like a real teacher when I do this. Oh, let's see. I have no idea. There you are. What are you doing over here? All right, guys. Now, this is going to be a little bit funky. Just to warn you ahead of time, it's going to be a little bit funky. So what I'm about to do is I'm going to develop a new equation of a line, which is always a little bit difficult. It's sort of like the math equivalent of watching sausage get made, right? It's not a good experience. Just stay with me. Here is the equation of the slope between 2 points, right? If I have a line, if I have a line, this line exists, does it matter which 2 points I pick?
No.
Yeah, if it's a straight line, it shouldn't matter what 2 points I pick. If it was a curving line, then it totally matters which points I pick, right? But it's a straight line. This equation doesn't need any specific points, right? So let's just say this. I do need kind of a starting point. So somebody says, okay, it goes to the point x1, y1. So they give me a point. Doesn't matter. It like Vu just said, it doesn't matter what other point I pick. It's going to be the same slope. Is everybody with me on that? We know that for sure, because if the slope changed, it would curve. And it doesn't. It's a straight line. So I can pick any other point I want to that's on the line, any point. And the slope will be the same between them. Whatever point I pick, the slope would be the same.
It's like stairs.
Exactly. You could jump down a few stairs, or as you get older, you could stop doing that as much. Right? I still do sometimes, but not as much. So let me rewrite this. I think everybody gets that idea. So now this is just going to look like this now, where this is a specific point, but this is any point. So in algebra, when something has a subscript, that means it's specific. It's specifically something. When it doesn't, that could be anything. So y is any y part of the line, and x is any corresponding x part of the line. Now, all right, maybe this is not as funky as I thought it would be, if everybody's with me so far. All I did was, it doesn't matter. This says I have to use 1 point and this other. No, I can use 1 point and any other point I want. And I'm going to get the same slope. So now watch what I'm going to, let me rewrite this a little so I can get rid of my boxes here. What happens if I multiply both sides by x minus x1? These cancel, right? You guys with me? And some of you guys, this should look familiar now. Let me write this here. Y minus y1 equals, let me write m times x minus x1. That is the new equation of a line that goes along with mx plus b. Math people being very creative people. Oh boy, am I laggy? Oh shit. Wi-Fi, okay. We said to ourselves, hey, it's got a slope and a point in it. So let's call it point break. No, point slope. This is called the point slope form of the equation of a line. So how the shit does this work? So what I want to do is I want to kind of redo the problem we just did.
So all you need is the slope and a single point.
Yes, any point. You don't need the y-intercept to use this equation. You just need any point. So the one we just did, oh shit, somebody help me out. It was these 2 points here, right? 200, 8,500, is that right? The one we just did?
Yes.
Yeah.
Okay. And the slope we got was 40. That's not going to change. But now watch. This isn't better. This isn't easier. It's just a different way to do it. Now that I have a new equation to work with. So how would I use this equation? Well, m is 40. Okay, that's great. And now I've got to pick a point. I'll put the x piece of the point here and the y piece of the point here. Right? So I just pick a point. I can use either point. Why does it make sense that I'll get the same equation if I use either point? Because both of these points are where? Is my Wi-Fi doing okay? I'm all freaky laggy. Am I coming through? Are you guys all right? Okay, all right, I'll take that as a yes. Let me try this again. What did I just say? I forgot. Shit.
You said both of your points are where?
Thank you. So both of my points lie
Or on the graph.
They're on the line. So that's why either one works. Are you okay out there? All right. So pick a point. Which point do you want to use? I don't care. First or second?
Go with the first one.
First one. That's crazy. All right. What's the Y piece of that point?
6,500.
Yeah. So that's where the Y piece goes, right? And what's the X piece of that point?
150.
150. So you get Y minus 65. Now I just solved this equation. Bring the 40 through. I don't know if you guys remember doing 40 times 150. We just did that a minute ago. And then you add 6,500. And you get the same equation we just got. Of course you do. We actually did the same work. It just doesn't feel like, oh, I am lagging. Shit. I checked my internet this morning. It was fine, but you never know. How's it going right now?
Do it again.
I'm not going to perform for you any more than I normally do. Stop. Okay. So let me just summarize what we just figured out. And actually, let's do a couple example problems. Same equation we got earlier, right? And if you really pay attention to what we did earlier, didn't we multiply 40 and 150? Didn't we subtract those two to get 500? I mean, it's the same work. It's just kind of all together in one thing now instead of kind of separate. So now we have y equals mx plus b, which I actually can use anytime, but I can use it directly when I know the y-intercept. And then we have y minus y1 equals m times x minus x1. That is called point slope. The more boring movie than Point Break. And then this is called slope intercept, crazily enough, because it has a slope in the intercept. So let's try another problem out. Find the equation. Holy shit, let me see. Calm down. Find the equation of line going through -1, 6, and 2, 15. I like it. So what I try to get people to realize on a problem like this, you need two things. You need the slope and you need a point. So this kind of focuses you. Figure this out. Figure this out. This one's easy because they give me two. I just got to pick one. Try to get as far as you can in this problem. Sorry, they're doing some kind of construction work on the next street over. It's kind of driving me crazy. I don't know if you guys can hear it. So in case you're, you don't have to do this, but I can label this x1, y1, and this x2, y2. That just means the x of the first point, the y of the first point, same thing. You don't need to, but you can. Because then when you go to do the slope, things just fall into place. y2 minus y1, 15 minus 6, x2 minus x1, 2 minus -1. And again, don't forget the idea. It's the same idea. How much does this change while how much does that change? That's all that equation captures. We've known that forever. What do you guys get here?
Three.
Yes, you'll get 9/3. So you get a slope of 3. I like it. Now somebody pick a point.
2,15.
11. And now, if you haven't done this yet, go ahead and plug in the stuff in the right place. Go ahead. I'll just stand here. Here, I'll do it over here. All right, let me catch up to you guys. So the 3 is the slope. It's going to go here. The y piece of the point we picked goes here with the y. And the x piece goes here with the x. You just distribute. Add 15 over, get the y by itself. How can I check my work? Well, let's take the other point. All right, so that's the answer. So now let me check my work. If I want to, I'm going to put a -1 in, and I'm supposed to get a 6 come out. That's what this guy says. A -1 input has a 6 output. Is that true? Yes. -3 plus 9 equals 6. Wow, you are strong. Jeez, get high off of you quick. Does that make sense to everybody? We've done that before. If I have the equation of a line, what is that supposed to do? It's supposed to go through all the points that I know. So how do I check it? I make sure it goes through the other point, the one that I didn't use. I know it goes through that point. I made it off of that point. Let me check the other point. Maybe. All right. So let's try here. Let me give you guys a problem to do. I'm going to erase all this. Let me see. Find equation. Line through, going through. What do you got, Jeff? Let's make it gross. Yeah. 11, -5. And let's see. Oh, let's see, Jeff. 6. 1. Sure. I like it. This one's going to be some fraction stuff happening. Yeah, buddy. Take this away. So go ahead and do that problem. While you guys do that, I'm going to look ahead. See if I want to come back in the book here. Let's see. Oh, of course they do that. Dorks. All right. Are you guys liking this problem? I like it. Of course I would. It's just so evil. So let me make sure you guys know you're on the right track. So if I wanted to, I could call this x1, y1, x2, y2. I could put in my y as 1 minus -5. That's one of the biggest mistakes I see is there's a minus in the equation and the y value is negative. You need both of those there or else everything's screwed. And on the bottom, I'm going to have 6 minus 11. So I get 1 plus 5 over 6 minus 11. I get -6/5. So that's always exciting. All right. And now this is kind of cool. Did who picked this point for the next step? Anybody? All right. That's okay. Everybody. So you all picked this one? Most of you? Why? Why? It's a really good point because it's got two things going for it. There's no negatives and they're smaller numbers. I don't blame you at all because you could pick either one you want to, right? So me, I'm going to pick that one. And let me see if I get the same equation you guys got, right? I'm supposed to, aren't I? I have to get the same equation you guys got. So the point I'll pick is this one. Let me see if I get the same equation. So y minus the y piece is -5 equals m is -6/5 x minus the x piece, which is 11. Oh, this is yummy. Oh, man, you guys really hate me. Negative times negative is positive. 66/5. This is exciting. Subtract 5. So let me make this have an LCD. So I got to multiply by 5. Right? That's not that bad, is it? Come on. -6/5 x. And then I get 66 minus 25 is 41, I think. All right. So let's see. Did you guys get that answer using the other point? Let me do it again with the other point. Just to show you it doesn't matter. So this is using the first point. Let me use the second point instead. So it'll be y minus the y piece, 1 equals m, -6/5, times x minus the x piece, which is 6. Y minus 1, distribute, add 1, which means add 5/5. Is that cool? 1 is 5/5. So we get -6/5 x plus 41/5. Huh, interesting. All right. So it doesn't matter which point you pick because there's an infinite number of points. They all lie on the same line. They would all give you the same equation because they all exist on the same line. Please let that make sense. That's why it doesn't matter which point you pick. All right, cool. I like it. Nifty. Okay, let's go back in the book. Everybody doing all right?
More or less.
Okay. I'm just getting less questions, but hopefully that means it's making sense. No idea what all the hand signals were, but oh well. All right, let's see. Get up here. So let's do this real quick. Oh shit, there you are. Okay, that's really weird. What is happening? I love you, technology. You're so awesome. Let's see what happens. What happened here? Okay, just everybody stop. Okay, you guys see the book, right? I don't know what's going on with my Zoom. It's freaking out. Let's see. Read through this real quick. All right, what the hell? Well, first off, sorry. Does anybody else have a question as they read through this thing? I have a question. I got to look this sucker up. Does this exist? What does this mean? All right, so you read this on a few different levels, right? It's a math problem, so you sort of keep an eye on the math and numbers. But digital locking cookie jar. Excuse me? What?
You don't have one?
Huh?
You don't have one?
Apparently not. Did I miss that? Was that a big thing?
Yeah, everyone
Does
has one.
everybody have a digital locking cookie jar? Everybody does. Is it like Alexa, throw me a cookie and it unlocks and a cookie comes flying out of her? You missed me, Alexa. Try again. It's like alter the angle by 27 degrees. They'll try, and then you just eat the
I
cookie.
don't need another device that can talk to me.
Yeah, exactly. I don't need another device that can listen to me, is the other thing. Your cookies are freaking telling you about whatever. Okay. All right. I'll get over that. I'm over that. Doesn't matter what it is. In this case, it just happens to be a digital locking cookie jar. So the 200 digital per week, which has led them to losing $150 each week. That's an awesome business plan. It worked in the 90s. According to this plan, their net profit will increase by $12 for each unit sold. So they are currently selling 200. Every time they increase that by 1, they'll make 12 more bucks. So they're probably interested in finding what point. What point have we talked about before that's important in business? Anybody?
Profit.
They are losing.
Profit.
But they want to start making profit, which means they want to find the point. What's the special point called?
Break-even point.
Break-even point. If you know the break-even point, then you know you just have to make X go beyond that and you'll start going into profit. That's why it's such an important point. So I'd much rather be at the break-even point if I was this company than where I am right now, losing $150 a week. It's hard to pay for groceries with negative money. I've tried. So let's see, what evidence do you see that this would lead? Obviously, this is linear. Can somebody point out to me why it's obviously linear?
It says increased by 12.
Yeah. Each unit sold will cause the profit to increase by 12. So it's lockstep. 1 up, 12 up. 1 up, 12 up. Obviously linear, right? Now take a minute. Don't say anything out loud. Identify each of these things. Don't tell them. Don't say anything. Identify the independent and the dependent variable. Let's see if everybody really understands these terms yet. Oh, let's do with this, Jeff. By the way, real quick, while I'm thinking about this, is there anyone out there who is not able to print something out if I send it to you today for tomorrow's class? Can everybody print something out for tomorrow's class? Okay, I'm not seeing anybody say no. Huh? Sorry?
I can't.
I'm sorry. All right. So you'll be watching things happen. Sorry. But I am going to send out a handout for tomorrow, and it will work much better if you're able to print it out. If you're not able to print it out, it might still work. We'll see. All right. So somebody tell me, what's the independent variable?
Unit.
Yes, unit sold. And what depends on that?
Money.
Money. Profit. I like it. All right. Go ahead and figure out number 3 if you haven't done that yet. All right. There's no work to do here, right? Hopefully you guys realize that. What is the slope?
12.
12. I love it. And more specifically, it's $12 per unit. But 12 mathematically beautiful with the units. There it is. How do you know that? Because they tell me. I mean, it's really nice when they do that. All right. All right. So let's continue. I'm going to clear all this so I can continue. I really wish I could do this a different way, but I currently don't know of one. Clear. All right. So now, can somebody tell me, do we know a point? Do we know a point that this line is going to go through? Do we know a point from
Yes.
this problem? What
Yeah.
point do we know?
200 digital jars and the negative 150.
Yes. So let me write that down here. Oh shit. Come back up here. All right. So you're going to need this. So we know that when we sell 200 jars, we get negative $150 profit. Oh shit. And we know that the slope is, I already forgot, was it 12? No, 40. No, 12.
12.
12. My God, Jeff. my memory is strong, but really short. All right, so go ahead, do it either way you want to. Figure out the slope intercept, which is this. But if you want to get there starting with this one, feel free. So just take a minute and figure out what that equation is. This time it's kind of nice. We only know 1 point, so you don't have to choose anything. What is that supposed to be, Jeff? An arrow? Yes. see, has anybody figured out the answer yet? Not yet. Okay, take another minute. Okay, you got it. Okay. I'm going to do it both ways. I think I'll start with this way here. All right, did anybody do it this way with the new equation? No.
Yeah.
Yes. All right, so let's try this out. So what'd you get? Y minus what goes here?
Negative 150.
Oh, shit. My mistake. Hold on. I got to make some room for that. Okay. All right, let me catch up. All right. So yeah, the y piece is negative 150. So be really, really careful. The minus is a part of the equation, and then the value itself is negative. Sometimes people write the minus sign. They're like, I already wrote a negative sign. Why do I need another one? Because you want the right answer. And of course, what goes here is just going to be the 12. And then what goes here?
200.
200. I love it. And then if you do a little bit of stuff, this will be y plus 150 equals 12x. Shaboo! Minus 2400. And then you subtract 150. I get y equals 12x minus, yeah, okay. I don't know why I got all cross-eyed there for a minute. Is that what you guys got? Anybody got that?
Yeah.
Let's see what it looks like the other way. So I would put the y piece here, 150, negative 150. Then the slope, then the x piece, and then plus b. This is what I don't know. I'm going to try to solve for it. So negative 150 equals 2400 plus b. So I subtract 2400, subtract 2400, and I get negative 2550 like we just did already. Bam, right? So both ways work crazy. All right, so keep track of this for me. Does anybody have any questions? Anybody have any difficulty with that? So let me remember what this might mean physically, this negative 2550. Business-wise.
Overhead.
Overhead, I love it. So however much they have to, spend on research and development and creation of the things, materials and labor. I love it. Okay. So somebody, yeah, you all keep track of that for me. I think we're going to need it here again. Let's find out. I'm going to clear all this away. Here it goes. Bye. Okay. Oh, all right. So let me write this equation down again. Oh, we already talked about part 5, didn't we? We just said what the y-intercept is. All right, here comes number 6. We all knew this was coming. I don't know why I'm so excited about a cookie jar problem, but I just am. Just deal with it. So y equals 12x. Somebody help me out. Was it 2550? Is that what we just got?
Yes.
All right, thank you. Help out this old man. I used to have such a great memory. That's a lie. So take a minute, figure out the break-even point. And just to remind you guys, where does the break-even point happen? What's another name for the break-even point?
The Y-intercept.
Not the y-intercept.
The X.
Yeah, yeah. Because what's break-even mean? You make 0 profit. So you want your y to be 0. So you got to figure out what your x is. So the break-even point is when the output is 0. So that tells you how to do the problem. You let y be 0. So go ahead and do that real quick for me. Making you all work. Well, I mean, shit. You don't have to be working, especially if your camera's not turned on. I don't have a clue what you're doing. But do try this out, please.
If it makes you feel better, I don't have a camera.
Thanks, Ian. Doesn't really change. It doesn't really change how I feel, but good to know.
I would have it on if I could.
No, I appreciate that, man. I appreciate it. God, I can't wait till we're. That's gonna be weird to be back in the classroom. I'm gonna feel like I'm just starting to teach again. That's gonna be strange. I don't want to go through that again. Those were weird days, man. All right, let me see. So how do I do this? I do like I said, set y equal to 0. And then you solve. And this is a relatively simple equation. How did somebody choose to solve this? Well, what was your first step here to solve this equation?
Add 2,050 to both sides.
Yeah, if I add this to get the numbers on the other side, and then of course you just have to
Divide by 12.
divide by 12. Let's see, what is that, Jeff? 212.5. Is that right? 212 and a half?
That's what I got.
You got it.
So obviously to break even, they have to sell 213, which actually they're gonna make a little bit of profit. If they sell 212, they're still negative. That's a bad thing. So mathematically, it doesn't have to come out to something that makes sense. It would be really strange if somebody's like, I just want half the jar. Is that all right? So we're actually in the real world, we would make this 213 would be our target to start making profit, right? The math can come out however the hell it comes out, and then we interpret that for the real world. Okay. And I mean, the rest of this we've done already. This one is interesting because you got to pick a good scale. So we already know this first thing here. Well, actually we don't. What are we talking about? Well, yeah. All right. So let's go ahead and do this. What's this first point going to be? What's the name of this first point? What is it also known as?
Break even.
No. Break even is if y is 0. This one is x is 0.
The exit or the Y-intercept.
Y-intercept, kick ass. So the Y-intercept is definitely negative 2550. We kind of already knew that. That's going to be our overhead. That's how much we have to owe no matter what. So if I don't sell shit, I'm in the hole 2550. That's not good for us. Go ahead and finish this out. There's only 3 more points. And again, all of this should feel very familiar. The one new thing in this section is just that slightly new formula, but everything they want you to do with it is the same. So it's actually good if you're a little bit bored. It's a good sign. I believe this is the point that they gave us earlier, right? They sell 200, they lose 150. That's what they were doing. Remember that? So it's nice to see that come back. We already knew that was a point. Holy shit, Jeff. All right. Is that right? I think that's right. All right, and then finally, if we plug a 600 in there, and hopefully somebody's doing the shortcut out there, but this is what it looks like if you use the equation for every single one of them. What is that, 7,200? And then whatever the hell that is, 4,150? No, 4,650. Is that right? I'll see if I use the shortcut. Every 200 is 2,400. Yep, there you go. Okay. Now, the real question on this problem is what kind of scale are you going to use? So the x-axis and the y. So what scale should I use on the x-axis? Like,
200.
yeah, you don't mean make this 200, do you? Like I would make this 200, this 400, and this 600. Is that all right? Just to give myself some more room to play with. And what about the y-axis? What should the y-axis scale be? This is kind of funky. I got some negative stuff going on. I've got some positive, big ass positive stuff going on. It's going to take a minute to figure out maybe what our scale should be. And some of you guys, if you use the slope is 12, right? If this is 200, this step here is 200. Maybe I want to use this step to be 12 times that. That's not a bad idea. So if I make this, let me do this in different color because I got too much stuff happening. So make this 2,400 and I make this 4,800 there. Let's see what that makes this. 1, 2, 3, 4, 5. All right. I don't know if you guys are going to be with me on this. I don't know. Maybe I'll take anybody. Well, let me go ahead with this. Let me see if you guys are cool with this. Do you see how if I put 2,400 and 4,800 there, and then if that would mean that this would be 2,400 here, does that work? That might not be a good idea because how low do I have to go? I've got to get down to here. Are you with me? So that's not a good choice. And that's a part of math is actually trying something and it doesn't work. So you go, well, that wasn't the right thing to do. Does somebody have a better slope they want to use? Or I'm sorry, scale they want to use? Because this is a huge part about making a graph is determining what scale I should use. So if I need to make it down to, if I need to include 2,500 down here, 2,550, right? Maybe I can make this 3,000. Let me get this out of the way. Sorry, let me move some of this stuff here. We don't need this anymore. There we go. Stay with me now, watch this. To make this 3,000 negative, then 2,550 has a place to be on there, right? And this is 1, 2, 3, 4, 5 steps. 3,000 divided by 5 is 600. So this will be steps of 600. Same thing here then. This would be 600, 1,200, 1,800, 2,400, 3,000. Let's just go ahead. So that's 3,000. This will be 6,000 here. Oh, let me erase this stuff. Are you guys semi with me at all? Because this is something we've touched on several times, this idea of picking a good scale. And this is something that a lot of students sort of don't think about. And then everything they do kind of sucks. Let me see, let me make sure I'm on the right track. Yes. 3,600, 4,200, 4,800, 5,400. Okay, all right. And now I can plot my points. 0, negative 2550 is about right there. 200, negative 150 is really close to that. 400, 2250. 2250 will be in between these two. Let's see. Well, almost exactly in between. Make that big point there. Make a big point. Point. Make a big point. Okay. And then 600 is 4650. So about right. Let's see here. All right. And then if I try to draw a straight line, let's see what happens. This is very exciting. Oh my gosh. Holy shit, Jeff. That's really good for me. So look what we got for the break-even point here, 212.5. So this should sound exactly like an earlier homework. Can you see where that is? That's right there. So with my line, it makes sense. Looks to be a little bit above 200. So 212.5 makes sense. Break-even point. Okay. So that one's always a tricky part of graphing, is picking a good scale. A lot of students have trouble with that. And I'm really sorry I had to write so small in there, but I won't. All right. I think that's enough for today. Anybody disagree? You want more? Anybody want more?
No,
I don't. What's that? No? All right, that's enough. So let me know if you have questions, if you need to hang out after class. Otherwise, you are free to go, and I'll see you tomorrow.
Jeff,
Yes.
you said you were gonna put something for us to print out for tomorrow,
Yeah.
or
Yeah. When I put it up on Canvas, I'll send an email out.
okay.
Yeah, and then print it out for it so you're ready for tomorrow.
All righty.
All right.
Thank you.
Anytime. All right, guys. I'll see you later. I don't see anybody with questions, so I'm headed out. Bye, everybody.